Welcome everybody. We'll get started here. It's a little after 11 o'clock here Central Time. I'd like to thank you for joining me today. Today's webinar is going to be on GeoWeb for rail stabilization. A little about myself. I've been the chief engineer with Presto for the last 18 years. Prior to joining Presto, I was a consultant, 20 years focusing on all different types of civil geotechnical projects. I'm an active member of AREMA committees, both 1 and 5. I'm also a member of ASTM, D18 Soil and Rock, and D35 Geosynthetics, along with ISO Technical Committee 221 on geosynthetics. So here are the key takeaways I hope you gain from today's presentation. Understand the benefits of a GeoWeb stabilized ballast supported by research and testing. Learn how the GeoWeb can reduce ballast pressure along with particle or ballast movement. Discover all the flexibility and the versatility of the GeoWeb system, and explore how GeoWeb can be used for slope and earth retention. I have some slides at the end here that I'd like to go over on slope and earth retention. So Presto worked with the Army Corps of Engineers to develop geocell technology back in the late 1970s. We continue to be the leader in innovation. We do offer more than just a product. So we do offer a complete solution. We will work with you from the initial concept phase right through construction. We have a fantastic worldwide distribution network experience, not only in our GeoWeb technology, but also other geosynthetics as well. So like I said, once it goes to construction, we're going to have someone on site from our worldwide distribution network or one of our team members. We operate in 4 product areas using our GeoWeb geocells. We can do load support, slope protection, channels, and walls. We also offer different types of porous pavements. We offer a GeoBlock, which is a vegetated, and a GeoPave, which is an aggregate solution. And we also have construction mats, or GeoTerra construction mats. So I'd like to discuss how the GeoWeb system. So the GeoWeb system consists of 2 real main attributes. The first is the cell size. So the cells come in 3 different diameters, 8.5, 10.5, and 18 inches. The cell wall heights include 3, 4, 6, 8, and 12 inches. So really the actual cell size and the height will depend on your site-specific details and your conditions. We will provide free evaluations, which I'll mention a bunch of times through our presentation, but a free project evaluation we do provide for every single project, no matter of the size. A free project evaluation will consist of a written summary, cross sections and plan views, calculations and specifications. And once again, no matter how big of the size, I highly recommend for any of your projects reaching out and getting a free project evaluation. The ultrasonically welded seam, basically where all the connecting points are located, is extremely critical for the function of a geocell. So the stronger the seam strength, the better performance of the geocell. A strong seam really allows for better lifetime performance. We use GeoWeb, we've been making it for the last 40 plus years out of a high quality virgin HDPE resin that provides consistently strong seams while also maintaining a long and durable seam. So we don't use any fillers or exotic polymer alloys, which can ultimately really reduce the weld strength. And trust me, we've tried all kinds of different blends, but even recycled materials. But like I said, 100% HDPE is still the most efficient and longest lasting geocell. Here you can see a typical panel. It comes tri-folded on a pallet. Typically ships anywhere from 12 to 20 sections on a pallet. Ships very efficiently. Usually you get about 44 pallets on a typical truck, a 53-foot van. So you're shipping 100,000 square feet of material plus. So it really does ship very efficiently. You can see each panel has a nominal width of 8.5 feet. Depending on our project evaluation that we do, it comes in different project or different panel lengths. You can see the picture right here showing one of our nominal. This is a 29 cell GeoWeb panel. That's about 27 feet long. But we also can make standard panel lengths if the project is large enough to reduce the amount of waste. So once again, we'll work with you on that during the project evaluation stage. To ensure the system really does good performance. I can't mention enough that, we really do want to have really strong seams. That's both the factory welded seam, which are the internal welded seams, and the field joint seams. So those are the mechanical junctions that consist, or basically, tie each panel together, whether that's end to end or side to side. So, we use, like I said, that 100% virgin HDPE blend that we've been using for 40 years. It's going to last for, well over 100 years if it's even subjected to 24-hour direct sunlight. So it's really a long-term performance. We add carbon black to the material for UV degradation. If it's our walls, which I'll show you some pictures of in some slides, we add a high HALS content. If it's subjected to UV for walls and it's a colored geocell. All of our the GEOB and all of our accessories are 100% made in the U.S. Under a strict quality control and assurance system. Basically we'll comply with all the requirements for the Build America, Buy America, and the Infrastructure Investment Act. We can provide certifications for, not only the resin, which we also procure here in the United States, but all of our accessories and the GEOB panels, if that pertains to a project that you're working on. So, the system components, are very, very important. It basically allows the system to perform in a uniform manner. We have all kinds of different accessories that we've developed over the years to really speed installation, but also not only to speed installation, but provide a very stable system. So you've got some pictures here where you're looking at, a slope presentation or a slope project here. We have, tendons that we're going to use after tendon clips, load transfer device, but really our biggest connection is the AtriKey connection device. That's used on all of our projects, whether it's a load support, slope or channel project, or even our walls. That is the key driver of an successful project. The AtriKey is, like I said, connect the panels, end to end and side to side. They really do speed up the installation. They're made from 100% plastic. They'll last a lifetime with the project. They really do ensure that the panels will not separate and not fail under anticipated loads. So it really does make sure that it holds up over time. When we originally started with the GEOB back in the 70s, we actually had metal staples, and you can imagine, those are going to degrade over time and potentially could lead to some issues with panel separation. Whether it's a load support channel or slope, even a wall project, we don't want any degradation to happen. So, here's an up close photo of the AtriKey. If you look at the top and the bottom, we've recently added frictional barbs. These barbs really do help the lockup between the cell wall and the AtriKey. You can see, the barbs on the bottom, but also on the underside of the top of the key, there's the frictional barb we added there. And what these do is they really provide added protection against the 3 failure modes of a field junction, and that's shearing, splitting, and peeling. We evaluate the factor of safety for the AtriKey connection, all of our projects as part of the evaluation. So we look at all the potential failure modes, like I said, shearing, splitting, and peeling. So it's really very important that if you're looking at a geocell project, that whoever is providing calculations, that it includes a specific calculation for mechanical junction, including the factors of safety for shearing, splitting, and peeling. So you can't just say it's 100% connection. You got to make sure that you actually connect or provide that calculation for each specific project, because each project will have different requirements. Just want to briefly show you, these are some of the things that we come across in the field. We developed the AtriKey. Really the main intent was to provide a permanent connection, installed effectively, no power equipment, generators, hoses, staplers, based on feedback from contractors through the years. They always said it's important to provide a connection that, maximizes the strength, but also one, really more importantly, is safe to deploy for the construction crews. So you can imagine if you're having pneumatic staplers and hoses and generators out on the site, there's a lot of tripping hazards. You can see the picture here is, there's one of our competitors uses actual hog rings. You can see 2 people hands close to the hog ring, so you get a lot of pinch points, like things like that. So really the AtriKey not only provides a permanent and long-lasting connection, but we wanted it to be a very safe connection. So just make sure you're aware of, what that manufacturer is providing for a type of connection. So, the purpose of GeoWeb is pretty simple. It's really to stabilize the movement of unstable soils, like I said, whether that's vertically or horizontally. Once again, you can see the different 4 points: the load support, slope, channel, and retaining walls. How does it work? GeoWeb 3D confinement is, it's pretty simple. When you have a vertical load, accessing a geocell panel, the main intent is you want to get that vertical load as horizontal as quickly as possible. You want to get that vertical load acting with the friction angle of the infill, getting that load horizontal, so it gets into stress and strain with that cell wall. So it activates the hoop stress in the cell that it's loading, but also activates its internal earth pressure. It activates the passive earth pressure in the adjacent cell pushing back, and all those work together to support the given load. One of the advantages of geocells is that we can use the low quality friction angle materials, coarse sands, recycled materials, recycled concrete, sandy aggregate mixtures, basically the 20-degree friction angle materials. It does really give us a benefit because, the lower the friction angle to a point, the faster we get that vertical load engaging with that cell wall. So like I said, you'll probably hear that many times through the presentation today, but like I said, that is a very important part of a geocell when you're comparing it to other geosynthetics, such as, the grids and textiles that really do require, high quality, high friction angle infill materials. So just a little picture here on what these supported and supported and unsupported look like for a geocell. You can hear for typical supported, unsupported, you have your high stresses at the interface between the tire and the surface. You got your reds and your tans, typical 45-degree distribution of your pressure bulb. And here's what GeoWeb really does. We call it the mattress effect. And what it is basically just significantly increasing the spreading of that load. GeoWeb can, really reduce or eliminate all these high stresses at that subgrade interface. Increases that pressure bulb to at least like 60, 70 degrees. Rule of thumb for an geocell, and when we're talking about stress distribution, especially over low subgrades, is we can reduce the pressure reaching a subgrade by at least 50%. So if you're looking at stress distribution, rule of thumb is at least 50% for a geocell. Once again, the infill materials can be that low quality, low friction angle, the sands, salvage ballast. I'll show you some couple of slides here where we actually can use recycled or salvage ballast to really save money and save time on your projects. Here, could you see the impressive load support benefits? When I talked about the, that vertical load being supported by one, really one loaded cell and the passive earth pressure pushing back. But, we took this picture up in Canada. This is up in the oil patch. Really low subgrade CBRs, like around 1% or less. This is a fully loaded AASHTO H20 dump truck. So you're looking at wheel loadings of around 16,000 pounds, 110 PSI tire pressure. That basically what they're doing is they're backing up and dumping the sand layer onto the geocell before it's pushed out and compacted. But here you can see, like I said, only one cell really is supporting that load. So really is a very, if you ever felt a geocell, there really is no strength to it until it's actually, backfilled and compacted, because it's just made out of plastic. So, but once it's backfilled and compacted, very excessive and strong strength to it. So talk a little bit about some research and testing. The first one we did was back in the early 90s at the TTI Center out in Pueblo, Colorado. I'm sure a lot of people are familiar with that. It's, pretty much, a lot of the railroad work is done and has been done over there for years and years. They have 50 miles of track. They have a bunch of different loops. We did the testing here on the high tonnage loop. We had a 700-foot section that we compared, unsupported and supported a geocell. For this one, what we did is we brought in a low quality Mississippi mud, it was called. It was a really high plastic clay, CBRs, way less than 3%, at a 30% moisture content. And, with the unsupported, you get higher pressures. You get that really high concentrated load and high pressure on the ballast, which is really going to squeeze that clay upward and contaminates the ballast. We've all seen that, and I'll show you some, pretty good slides that would not happen. So this is something that you can have a lot of tapping. Here you can see just another with the GEOB supported load. It basically distributes that load over a larger area. Significantly reduces the ballast pressure. Like I said, about a 50% at least reduction in that ballast pressure. So this was a 2.5-year test. Couple 100 million gross tons were applied with a 315 kip car, but the results were pretty impressive. So without GEOB, they required tamping, basically every 1 million gross tons, to maintain that track profile. But with the GEOB and over 206 million gross tons, we kept the alignment. It never really exceeded 30% of the allowable limit. So, and even actually to a point was it never really started to degrade. So they came in and they dumped a couple 100,000 gallons of water in it, trying to mimic a 500-year rainfall event. Saturated and got that expansive clay, and really there was no significant effect that was really observed. So very successful. We relied on that study for years. Just recently, a lot of the class ones, understand how GEOB saves them money, but really don't understand how it works. So we went ahead and went to the lab and did some additional testing with the University of Kansas, who did the research. Oregon State performed, finite element analysis modeling. We looked at each test. We looked at earth pressure cells. We also used smart rocks which included motion vibration sensors that record how that ballast particle moves. So the research was conducted, like I said, at the University of Kansas. Professor Ihan, who has been researching geocells over 20 years, was in charge of the research. Ben Lashinsky, who did his PhD on geocells, did the finite element analysis, and Professor Hung from Penn State provided the smart rocks and the smart rock technology. Uh-oh. Just locked up here. Apologize for that. Basically to look at that ballast, how the movement, like I said, we put those smart rocks. We put them inside the GeoWeb panels here. But I also wanted to see the movement between the ballast, the top of the bottom of the tie and the top of the geocell panel. So we had a 12-inch ballast here. So we put those smart rocks 6 inches below the tie and 6 inches above the geocell panel. So here you can see how the smart rocks measure both the movement and rotation of those panels. So you can see here how it measures the rotation of that ballast particle. And also how it measures the movement of it, when it's subjected to a train passing over it. So here the slide shows, basically the velocity, and that's the rotation, of that particle. You can see you're looking at two different smart rocks here. We had below the tie, so six inches below the tie, 6 inches above the GEOB, and then a smart rock inside the GEOB. So, you can see our control section here. Without GEOB stabilization, significant rotation, degradation of the ballast particles. Here, once with the GEOB, reducing that stress on the subgrade, you get significantly less rotation and movement of that ballast particle. And then you can imagine just inside of the GeoWeb, this is about 12 inches below or 15 inches below the bottom of the tie. You're getting the stabilized section, and then also with the GeoWeb. Once again, with movement, this slide does show the angular acceleration of the movement, side to side and up and down. Once again, below the tie, you're looking at in your control section a significant amount of movement, side to side and up and down, with your stabilized, below the tie, which, like I said, 6 inches below the tie, 6 inches above the web. You can see a significant amount of reduction between that ballast movement. So this research really did confirm that, GeoWeb does significantly reduce the ballast tamping and the maintenance, because it really does stop the movement of those ballast particles. So you're going to really get rid of the abrasion in that ballast attrition. So That Smart Rocks really did show how that was. We also did the finite element analysis, just to confirm other research studies that we've done that, GEOB, how the stress reduction benefits. But, GEOB used in a ballast application really does decrease settlement and subgrade pressures by at least 50%. So you get a significant reduction in the settlement, but also the subgrade pressure. So if you're interested, we have some independent research summaries from University of Kansas and Oregon State, if you'd like to use those for your file or show them to your owners. So I'd like to go through some case studies, some rail applications. We can use GEOB on pretty much any type of track application, whether it's, mainline track, heavy stress areas, bridge abutments, crossings, turnouts. We've been using under track for 40 years. So we have, hundreds and hundreds of case studies and, interesting rail applications from scales, culverts, bridge abutments. So I'll try to cover some of those. But here's a project we did up in Canada, northern Canada. You can see the subgrade was really poor. Subgrade CBRs, 1 to less than 1. This line was a continuous maintenance, area for the railroad. You can see significant pumping and settlement inside of that track area. This was about a mile long section. They had a lot of issues with ballast contamination and pumping. Here you can see how contaminated that ballast is on the track. So, just a video that shows, every time that train goes over it, what kind of how that rail is actually moving in the tie. So a significant, reduction in the movement of that tie. So you can really see how that tie and rail is moving every time that train goes over it. So this is, was led to a lot of pumping, a lot of maintenance issues, and really there could be a potential for actually leaving the track. So they looked at us. We did a full evaluation. We worked with the engineer and the geotech, came up with the GEOB stabilized solution, which consisted of an enhanced woven geotextile. This is a Mirafar RS580i, high strength, high flow fabric. We used it for subgrade stabilization along with the GEOB. Interesting on this project in this slide is that on this one, the subgrades were so low CBRs that we actually went with factory seaming. We follow AASHTO M288, which is a highway spec, based on CBRs and overlaps. Since this is a CBR 1 or less, it actually recommends a minimum of a 3-foot overlap. You can imagine if, how much on this 1 mile of track, a 3-foot overlap is going to waste a lot of fabric. There is an additional cost. You have to factory seam that geotextile, but the cost is more than recovered when you're limiting that 3-foot overlap. And if you've ever been on a construction site, whether it's rail, a load support highway, and you're trying to do a 3-foot overlap, it's extremely hard to have a consistent overlap, but it's very hard also, especially if it's windy out. Those fabrics want to blow around almost like a kite. So highly recommend for large areas or really low subgrade CBRs to look at factory seaming. All the geotextile manufacturers can provide factory seaming. So, just here's the installation of the GEOB. They said it was in a really remote area, so they used some bigger particles that were available up there to fill the GEOB. It was more or less a 2-inch crush. Here's just putting the track and the ties back and finished installation. Here's another project that we did a couple of years ago. This was down in Louisiana. We actually had to cross a sugarcane field. Really poor CBRs, you can see here, high groundwater levels, CBRs less than 1. And you can also see how that track is between 2 tracks. So really the water gets sort of stuck. So it didn't really want to flow that far. So here we came in, did a design, due to that slope or the low CBR and the strength, we actually had a 12-inch base underneath the GEOB here. We took that RS580i once again and run it underneath and up the sides. And what we like to do, especially where we have a base underneath the GEOB, or if you're looking at any kind of rail project or road project where you have a subgrade or a sub base, you want to make sure that you wrap that geotextile around the sides. so you don't lose any of that material. Once you start compacting and you get cyclical loads, it's going to push that, squeeze that material right out. So you want to make sure you basically burrito wrap the sides. So here you can see just a closer picture how we're spreading out the GeoWeb, backfilling it with that aggregate, and then once again we'll just burrito wrap that right over the top of GeoWeb so you don't push that 12-inch base out into the poor subgrade. Here's a track we did down in Columbia. It's about 10 miles of track. This was an interesting job because the subgrade, wasn't really that bad. It was a CBR of about 3. The biggest issue is that, they had a fouled ballast. It was for a coal line. So a lot of coal fines were getting into and contaminating the ballast layer. So they approached us. We worked with the engineer and the geotech. Once we provided the design with an enhanced woven geotextile, you can see that getting installed. And also 2 panels of GeoWeb. So each panel here, a typical track for us, usually is a lot of times 17 feet wide. You can see connecting the 2 panels together, extending over the GeoWeb and the geotextile. Interesting one on this job is that we used the existing ballast. So what we did is we stockpiled that onto the site, and we basically used, you can see here, if you look closely, it's not a very good high quality ballast. You can actually see some pretty big, basically rocks inside that. They did go ahead and basically remove all those prior to putting the ballast layer in. But, if we can have a material less than about 15% fines, we can use that for a GeoWeb infill. So on this job, like I said, it was about 10 miles of track, 6-inch GeoWeb. They saved in about 16,000+ yards of material. So you can imagine how much of a cost savings that was. But, this was one of the mainline tracks coming from that coal mine. So, one of the bigger things also was time. We saved a significant amount of time on this job because we didn't have to, to bring in all new ballast. And here you can just see the salvage ballast getting spread out and compacted in place. And then, the finished installation after the ballast has been applied. We do projects all over the world. This is a project we did for Network Rail, just the biggest rail provider over in the UK. This is a project they had on their northern hub, parts of the track. Very low subgrade CBRs on some of them. They basically range from 1% to 3%. So, as a result, the standard required depth of track that they used could have been as high as 1 meter. Which, as Network Rail just determined, it was really way too expensive to do that. So the Network Rail investigation team was pretty much tasked with finding alternative design solutions, to reduce that cross-section depth and to lower the cost. So their in-house team did some numeric modeling along with our Presto design method, and actually with the University of Kansas testing that I showed you before. That modeling was used to quantify, the reduction of the track bed of GeoWeb was used as a solution. Here you can see the model used to iterate different layer thicknesses, compared that performance to the baseline values, standard track design. So, the iteration showed that using a track bed consisting of about 250 mils of ballast, 150 deep geocells filled with, basically a granular, low quality granular fill in a 50 millimeter sand layer would provide the same performance. It would save about 80 millimeters of construction depth. So it really did save about 40% in that reduction of that cross-section area. So here you can see just a couple images on installation. Here you can see the non-woven geotextile being placed over that sand bed, 150 millimeters, 6-inch GeoWeb panels going down, and basically the contractor just spread it out. But, interesting part is we actually had some continuous monitoring of this site. So, after the installation, the track opening in 2018, they really did monitor that track on a monthly basis. This slide shows that, for the worst areas, it can be noted that the track quality is significantly improved to an excellent condition. Here you can see, some of the original problems they had back in 2002. You can start to see how fast that track degradation came apart. Starting in 2018, we put the GeoWeb in. You can see pretty much a linear progression of that degradation. And that has not degraded anymore, since the last values that we got in 2020. So very successful installation, and no tamping has been required. So you can see the comparison between the track quality, at the 2002 renewal, and then after geocells were installed, in late 2017. So, you know, the 2002 ranged from 0.7 to 0.9 millimeters per year, and the GEOB deterioration value was only about 0.1 millimeters per year, so a very drastic improvement. So, you know, based on the success of those couple installations, actually, so we work with Network Rail to develop a guide. The goal was to really provide the summary of the research and testing and the design recommendations. So in August 2020, Network Rail issued the use of geocells and UK railway track bed. Once again, that design was supported by our Presso lab in testing at University of Kansas, along with the Smart Rock and the finite element analysis. So, you know, this guide was a reference for some other projects that we started and have been doing in the UK over the last 4 years. Here's the recent project we did. This is the Warrington Loop. This is a 2.5-mile track called, called the Warrington Junction. The aim of this project was really to increase capacity for passenger trains. So it involved building a couple new tracks tunneled under an existing line. This line opened in late 2021 and really did remove constraints caused by, sort of freight trains always seem to slow everything down, right? So, this one included the 6-inch geocells to increase track stiffness. You can see here that the contractor really wanted a precise installation, so they used stretcher frames, on this project to keep the panels open. You can see here's a low quality, local available sand fill, so very, very inexpensive filling of the geo panels before the ballast went down. And you can see as they're filling, you just remove those stretcher bars. Then compaction. Like I just mentioned one thing about compaction. So when you're compacting a GeoWeb, you want to make sure that you really only use, just use the roller. And if you need any kind of vibration, just make sure you use the light, really light vibration, because, typical contractors a lot of time will want to hammer the vibration. But, with the geocell or GeoWeb panels, you can actually sometimes move those panels, right out of the subgrade. So if you're on site with construction, make sure that you start off with a light, or just a roller compaction, and if needed, just a light vibration. So bridge abutments in crossings. As we all know, bridge abutments are really high stress areas. You transition from that solid structure to a prepared subgrade. I hear it all the time. It's that bump at the end of the bridge. The good thing is GeoWeb is extremely successful at reducing that stress. Like I said before, that we can reduce that stress by at least 50% and also reduce and decrease differential sediment. So we've been doing, hundreds of bridge abutments over the last 10 years, basically consisting of an enhanced woven geotextile, a 6-inch web, depending on the depth of that bridge abutment. Sometimes we're going to have 2 layers of GeoWeb at the bridge abutment and then transitioning to 1 layer. So you're looking at either 30 feet or up to 60 feet of GeoWeb transition to reduce that stress of a subgrade, because it's extremely hard to completely compact against a bridge abutment for a contractor. So you're going to get some, consolidation settlement over time, and you're going to have to deal with that. We can't reduce, or eliminate the consolidation settlement due to the weight, but we can almost completely eliminate any settlement due to the stress of the trains going over it. So, we can completely almost eliminate any kind of differential settlements at a bridge abutment. So if you have any projects, reach out. We can give you some recommendations on some bridge abutments. So here's another type of project we typically work on with railroads is supporting, culverts or, or bridge abutments themselves. So this was a project replacing, it's a major rail line over in Australia for Queensland Rail. They had to manage these overland flows. So, the engineer came up with a couple different 6 by 10 meter culverts, beneath the rail embankment. So the biggest thing here was due to the poor subgrade strength, they needed to improve the bearing capacity, basically to keep that culvert from settling and differential settling. So, we worked with the engineer of record and also the geotech to come up with a couple different analyses. We conducted several design evaluations, determined the necessary working platform thickness, to achieve the necessary bearing capacity. So our proposed solution on this one included, multiple layers of geosynthetics. You can see on the photo here, we used an enhanced woven geotextile. We used actually a biaxial geogrid. So here we have the enhanced woven geotextile. Here's the white layer. On top of that, we added a biaxial geogrid and then 150 millimeter GeoWeb. So, it was a pretty robust system, but that's what, through the process, that's how we came up with when we did a finite element analysis. So, like I said, on this one, we were able to reduce the overall thickness by about 55%. So it was a significant reduction in a more stable system than the conventional approach. So here you can just see the finished abutment and the culvert crossing. So crossings and diamonds, do a lot of crossings and diamonds. You get a lot of stress areas here. This one is this is Union Pacific down in Cozy, Texas. This was adjacent to a concrete plant. So, they're having a lot of issues with this crossing because heavy trucks were damaging it. Basically, the starting and stopping of those concrete trucks, really leading to a degradation of this crossing and had to be maintained on a routine basis. So they actually ended up leg tying the ties in the track together and welded them. So, but that's still, even led to failure. So we had to come in and take a look at it. So here we did about a 40-foot on both sides for this crossing. The solution, once again, was an enhanced woven geotextile, 150 millimeters of GeoWeb and a 2-inch cover, and then the ballast. Another interesting one on this one. This was the first recycled composite crossing, and actually in the U.S. So, like I said, this was down in Texas. So, very successful project. Here you can see the first train going through. Really prior to even the finishing up of that crossing. But since then, it's been in service for almost 8 years now. There's been no settlement and no maintenance of this crossing. So most of the crossings we do, I've been on a lot of them, are overnight, usually Saturday nights, where track is going to be down, not a lot of trains out. So we'll start at midnight. The good thing about GeoWeb, it doesn't need any asphalt plants or anything special. They can install it with their own crews. You come in, you push the ballast to the side, you put down the geotextile and the GeoWeb, and like I said, we'll work with you on what type of geotextile and what geocell, and then put the ties back, and you got a crossing usually less than 6 hours from start to finish. So been on a lot where we start at 12 o'clock at night, we're done 4, 5, 6 in the morning. So once Sunday rolls around, that system's back in operation. So this is Tower 55 down in Fort Worth. It's one of the busiest in the country. There was 100+ passenger freight trains using this crossing per day. Due to the high volume and the slowness because of speed, they had to reduce the speeds because some of the degradation in that crossing. Delays could be up to like 90 minutes on each of those trains. So significant bottleneck for the passenger trains and the freight trains. So, this was a very important crossing for the Class 1. So they, due to excessive GeoWeb, they went with, once again, enhanced woven geotextile, 6-inch web, 2-inch wear surface, and then the ballast. So you can just see, the placement of that geotextile and the GeoWeb. Used a low quality aggregate ballast or GeoWeb infill, and you can see the replacement of the ties and everything going into operation, and the first train going through it. This one's been in service for about 8 years also, and once again, very, very minimal maintenance on this crossing. So for all of our rail projects, we're going to give you calculations. We're going to give you that free design evaluation, like I said, including the written summary, calcs, cross sections. Our method that I have put together here, we could use different types. It's in accordance with the REMA manual. I use the Talbot method for most of them. And our calculation method is pretty detailed. So it does include all the different input parameters. We input car weight, speed, rail weight, tie type, dimension, spacing, subgrade CBR. And we're looking at 4 different failure modes. So we're looking at the maximum stress in that rail. We're looking at the seat load. We're looking at the pressure on the ballast. We might want to make sure that ballast pressure is not higher than 65 PSI for conventional ballast or 85 PSI for high quality ballast. And then we also look at the track depression. We want to make sure that track depression is not greater than a quarter inch. So all things that are included in the REMA manual. So we'll provide those calculations. I'll walk you through them. A lot of these projects, we don't have the money or the time to do a full geotech evaluation or even field DCP test. So This chart I have, if you're interested, I've handed out thousands of these, over the last probably 15 years. What you can do, put it in your book bag if you're ever out on a job site. You need to design, a road, a railroad, or anything. You can basically do a visual identification. So if you look at this chart here, there's got different field IDs. So if you see a medium, is a man walking, sinks an inch, you tell me that. I can get a CVR off of that, and we can provide an evaluation for you, based on that field identification. So, like I said, if you're interested in that, please let me know, and we can. I can send those over to you. So, in summary, GEOB is very flexible in its design under track. We can do variable infills. Like I said, we really do use that low quality, low friction angle materials, coarse sands, aggregate sand mixtures, recycled materials. We significantly reduce the ballast pressure and the differential sediment by at least 50%. That research and testing, decreasing that stress really does significantly decrease ballast rotation and movement. So you can get a lot of, less ballast attrition, leading to less maintenance and saving costs. So once again, we'll give you a complete solution. We don't manufacture nor do we sell geotextiles, but we have a significant amount of expertise on them. So we will provide the type and the strength of that geotextile. So just like to touch briefly on slope protection and walls. So, along railroads, we're typically going to have a lot of slopes, a lot of channels. So, GEOB is very flexible. We can fill with aggregate, we can vegetate it, we can even fill with concrete if you want a hard armor solution. So this is a typical project. We did this is about 80-some thousand square feet. This is two sides of a rail embankment. Most embankments don't want to have vegetation. You don't want to see animals and things, getting up on the track. But, so they went, of course, with an aggregate solution, basically showing almost all the aggregate solutions. You're filling the GEOB from the top of the crest down. You can see it just filling from a car. Goes in very, very fast. You can see we'll provide, different anchorage methods for you, whether it's, basically we call them atra stakes or tendons that we support, like I said, at drapes. But, we'll work with you for a full solution and a full evaluation. Once again, fish and delivery from the top of the slope. You can see how they did underneath the bridge and going around to the other side. Like I said, about 80,000 square feet plus a GEOB. And here you can see just a picture years later, taken how, basically the GEOB confines the rock and prevents any sloughing due to, wind or rain erosion. So very effective. This is out in the desert. This is south of El Paso. Took these pictures, 3 or 4 years ago. This is a track for UP. Like I said, south of El Paso. They don't get a lot of rain, but when they get it, it comes down in buckets. So they were worried about the degradation between the track and the next track. So they used GEOB. Here they used a 4-inch deep GEOB, filled it with a 1-inch crushed rock. We do have from research and testing formulas to size the rock that goes into the GEOB infill. So we can help you with that. Typically instead of non-woven geotextile separation layer and the GEOB, here you can see just the extent from, the channels between, and we also did the slopes on the other side. This was about 500,000 square feet of web on this section of track. You can see how on the bottom they put the large riprap just to protect the area. Like I said, not a lot of rain, but when they get it, it comes down pretty fast. So, and here you can see how big that culvert pipe is, doing that drainage layer. So we'll help you sizing that rock, that goes in the GEOB and give a full evaluation for you. So, in summary here, once again, same, it's very flexible. We can fill it with topsoil and vegetate it. We can do aggregate solutions. We can do hard armor, concrete. We can even reduce the amount of riprap. A lot of railroads use it now. Riprap is getting very, very expensive. So if you combine it inside a GEOB, for instance, at the end of a culvert pipe, if you might come up with a 12-inch riprap for dissipation of stress and to knock that flow rate down, you can usually cut that by at least a factor of 10 inside a GEOB. So we can help you with that also. So a little bit on the walls, we can do gravity walls, typically limited to about 10 feet. We could do reinforced wall, really no limit to that. Pretty much, we've done walls up to 300 plus feet high. You know, GEOB for a reinforced wall is just a fascia. We'll give you a design with all the necessary GeoGrid tiebacks and all the infill parameters. You can just see a reinforced wall next to a bridge abutment. You know, we do these all the time. Like I said, you know, GEOB on the abutment can reduce the stress, but also for a wall, you know, you can significantly reduce any kind of stress, you know, reaching that subgrade. No, this is a project, this is a reinforced wall. This was prevent slope from a global failure and stabilize the line. So I like to show this picture because this is what it looked like in late fall when we put the wall up. And that's what it looked like by mid to late summer. You can see a complete full establishment of that vegetation in the wall. And you can't even really, so most of the time you don't even see our GeoWeb walls. They just blend in. So, but once again, we can fill that front fascia. If you're looking at a high stress area, it might get some flows. You know, we could fill it with concrete or aggregate. You know, a lot of the abutments or walls that are needed, it might be along the side of a creek or a river, things like that. We'll work with you on what type of things, what type to fill it in for the front fascia. So we do have a free design software. It's called GeoB MSE. You can literally design a gravity wall, reinforced wall, or even a reinforced slope for that matter, in a matter of like 5 minutes. So it's a really, really easy program to use. You basically, it was, you know, Dov Lashinsky, you know, Adam Engineering used to be a professor at the University of Delaware. He's been working on geocells for ever since they were actually invented back in the late 70s, early 80s. So very knowledgeable with geocells. He created this program. It's really pretty much an extensive of ARISA software that's used by FHWA for wall design. So, you know, we can run different modes. We can check internal stability, external stability. So, you know, it's going to give you a free, it's going to give you an output where you have all the calculations, the cross-section drawing, showing all the improvements here. So you'll show the GeoWeb, the height of it. You'll see the tiebacks of the GeoGrid and the strength. It comes with yearly updates. So every first of the year, I will send out a new program. Same password, just a new program, because we're doing upgrades to it. It has about 20 types of GeoGrids you can use, manufacturers, you know, for the tiebacks. But like I said, it's a free software. You can use it on any type of wall system. So, you know, in summary, like I said, it's very flexible. Once again, we have that MSE software. You know, we will support you 100% on any wall design, you know, whether it's for a bridge abutment or just straight track, you know, along the side of a wall. So got a lot of different ways we can help you on any type of rail project. So we have a fantastic website. It's at prestogeo.com. You know, we have a lot of tools. You know, we have product tabs, application design, installation. We have learning tabs. You can see here, we also have a YouTube channel. We have, you know, hundreds and hundreds of videos. And we have a learning tab here. If you click on that, you go into all the pre-recorded webinars that we have. So you can actually track your PDH credits. So if you sign up for this learning, you can take webinars and we'll automatically keep track of your PDH credits for you as you take your webinars. If you want a free project evaluation, you just click on that tab right there. That brings you to this form. Once again, you just fill out the information as much as you can. It comes to myself. We'll take a look at it. If we don't have the information, we'll give you a call. But you know, usually if we have the information, turnaround time is about a day. So once we get the RFP, give us about a day or 2 days max to get something back to you. After we get the evaluation, we'll hook you up with our local distributor. You know, as I mentioned, we get that worldwide network of distributors. So not only expertise in geocells, but also geosynthetic. So we do know that we're not the solution for every single rail project or project out there. So like I said, we do rely on our distribution network. If you come to me with a project that, you know, geocells might be a little bit of overkill, like I said, we'll work with our distributors to get you a solution, you know, might be a little more cost effective for that installation. So here, once again, just please go with stuff that you can trust. You know, we have 40 years of expertise. You know, we don't have any disclaimers on our specifications. As you see what you get. So, you know, let us be your solution provider. Always comes up on cost. Like I said, we're always going to be less than, say, other geosynthetic solutions, especially if you can use, you know, existing recycled and sandy materials, low cost infills such as low friction angles when you look at, say grids or geotextiles alone that, do require that high friction angle lockup. But, the best thing to do is reach out and, let us do that free evaluation. Then we can get you with our local distributors who can provide pricing. So that'll give you the cost. They can provide different costs for different types of solutions too. So you can take a look at the costs and the benefits for the GeoCell solution for the GeoWeb. So we trying to make it faster to get your PDH credits. Here's that webinar dashboard I talked about before. You can easily view, all the webinars. You can download PDH credits. We'll keep a record, as I mentioned before, of all the PDH credits and the webinars that you've taken. These live webinars are sort of managed separately, so you won't find your cert in there, from today. So you will receive an email typically a couple hours after we finish here with a link. You can be able to download your PDH certificate. So, in about, well, let's say in 2 or 3 days, if you don't get anything, please reach out to us and we'll get you that PDH credit. Sometimes, we do these webinars all the time and always seems there's a couple that somehow get lost in space. So like I said, if you don't get it in a couple days, please reach out. So with that, I really do appreciate you taking the time today out of your busy schedules to join us. And if there's any questions, you can see my contact information is here. So if you have any questions, if you want to reach out by email, just brian.wadeen@prestogeo.com. Also my phone number. I can answer a couple of questions. Are GeoCells feasible for large load bearing vehicles? Yes, absolutely. We really do shine with the heavy wheels. I've got case studies where we, basically transferred, LNG facilities over in Australia that are, wheel loadings of, 100,000 plus pounds, reach stackers, reach stackers on ports, intermodal yards, with wheel loadings, 200,000 pounds plus, 150 PSI tire pressures, we're subgrades as low as 1%. So yeah, like I said, the best thing is, just let us know and we can take a look at that. Let's see. The GeoWeb MSE software. Yeah, if you're looking for the software, just reach out to me. There's my phone number. You also can see it on our website. So if you go to our website under walls, you'll be able to see. You'll be able to see also a link where you can get the software, how type tapping is performed with the GeoWeb. So Geo is never in the ballast. It's always in the sub-ballast. So what we do is we, depending on the ballast, most railroads that I work with around the world, you're looking at a minimum ballast of 8 inches. That's typically the limits of tapping is 8 inches. So, we're always going to be about 8 inches below the bottom of the tie, so we don't get any that, the ties of the tappers don't get caught up in the GeoWeb. So like I said, we'll work with you on that, whether, 12, 10, 8-inch ballast, then the GeoWeb is below that. So someone wants a couple of people want a copy of that chart. Link to the MSE software. Yeah, like I said, that is on our website, or you can just email me at that brian.wadeen@prestogeo.com and I can send you the software. What's the track modules with GeoWeb? It all depends, on the subgrade strength, the type of car, the speed. So if you have a project, send me some information and I can run the calc really quickly and I can actually show you, what your result would be for a specific job. Like I said, I highly recommend not using any standard charts or graphs for any type of projects. Rail especially, it's not worth it. I mean, every project is different. Subgrade strengths are different. Speeds are different. Rail weight is different. Spacings are different. The tie spacing, the tie type makes a huge difference on the modulus. Your tie spacing is going to be really going to affect your distribution factor. So all these really do change our recommendations. So please don't use any standard tables or graphs. So make sure that everything is specific for your project. So And yes, we can, some people have already asked about calculations. Yeah, just, reach out by email and I can provide some calculations for you. Like I said, the evaluations, a couple of people have asked about the speed, 2 days max. Most of the time, we're getting back to you in a less than a day or that day. So like I said, we'll hook you up with our local distributors and they can give you costs. So, with that, like I said, please reach out if you have any projects. Sorry for my computer locking up halfway through. Hopefully I didn't talk too fast trying to catch up, but wanted to keep it to an hour. So if you have any questions, like I said, please reach out. And once again, thanks for joining us today. And I hope you have a great and safe day. Appreciate it.